Hello, myself Tanvais Reddy from first year of engineering and the CSC Cybersecurity studying in Sri Venkateswara Engineering of College. I'm going to explain about partial differential equations. A partial differential equation is an equation that involves an unknown function and its partial derivatives. That is, it involves two or more independent variables. The example x and t are the independent variables. Notation ux, which is equal to del x square u into x comma t divided by del x square. Uxt is equal to del square u into x comma t divided by del x into del t. The order of the partial differential equation is equal to order of the highest order derivative. Linear partial differential equation classification. A partial differential equation is a linear if it is linear in an unknown function and its derivatives. The example of linear partial differential equation 2uxx plus 1uxt plus 1utt plus 4ux plus cos 2t is equal to 0. Another one is 2uxx minus 3ut plus 4ux is equal to 0. Examples of non-linear partial differential equations are 2uxx plus uxt whole square plus 3utt is equal to 0. Root over uxx plus 2uxt plus 3ut is equal to 0. 2uxx plus 2uxt ut plus 3ut is equal to 0. Representing the solution of partial differential equation, two independent variables. Three main ways to represent the solution. Different curves are used for different values of one of the independent variable. Three-dimensional plot of the function tx, t. The axis represents the independent variables. The value of the function is displayed at the grid points. Heat equation. Thin metal rod insulated everywhere except at the edges. At t is equal to 0, the rod is placed in ice. Del square t into x comma t divided by del x square minus del t into x comma t divided by del t is equal to 0, where t 0 comma t is equal to t 1 comma t is equal to 0, where t x comma 0 is equal to sine pi x. A metal examples of partial differential equations. Partial differential equations are used to model many systems in many different fields of science and engineering. Important examples are Laplace equation, heat equation, and wave equation. Laplace equation del square u x comma y comma z divided by del x square plus del square u x comma y comma z divided by del y square plus del square u x comma y comma z divided by del z square is equal to 0, used to describe the steady state distribution of heat in a body. Also used to describe the steady state distribution of electrical charge in a body. Heat equation del u x comma y comma z comma t divided by del t is equal to alpha del square u by del x square plus del square u by del y square plus del square u by del z square. The function u x comma y comma z comma t is used to represent the temperature at a time t in a physical body at a point with coordinates x comma y comma z. Alpha is the thermal diffusivity. It is sufficient to consider the case alpha is equal to 1. Simpler heat equation del T x comma t divided by del T is equal to del square T into x comma t divided by del x square. T into x comma t is used to represent the temperature at a time t at the point x of the thin rod. Wave equation: del square u x comma y comma z comma t divided by del t square is equal to c square del square u by del x square plus del square u by del y square plus del square u by del z square. The function of u into x comma y comma z comma t is used to represent the displacement at a time t of a particle whose position at a rest is x, y, z. The constant c represents the propagation speed of the wave. Classifications of partial differential equations. Linear Linear second-order partial differential equations are important sets of equations that are used to model many systems in many different fields of science and engineering. Classification is important because each category relates to specific engineering problems. Different approaches are used to solve these categories. Linear second-order partial differential equations classification. A second-order linear partial difference equation is two independent variables AUXX plus BUXY plus CUYY plus D is equal to 0. A, B and C are the functions of x and y. D is a function of x, y, u, ux and uy. Is classified based on b square minus 4ac as follows. B square minus 4ac less than 0 is elliptic. B square minus 4ac is equal to 0 is parabolic. B square minus 4ac is greater than 0 is hyperbolic. Linear second order partial differential equation examples. Classification: Laplace equation where A is equal to 1, B is equal to 0, C is equal to 1, then B square minus 4AC is less than 0. Laplace equation is elliptic. One possible solution of ux, y is equal to e to the power x sin y, ux is equal to e to the power x sin y, uxx is equal to e to the power x sin y, uy is equal to e to the power x cos y, uyy is equal to minus e to the power x sin y, uxx plus uyy is equal to 0. Linear second order partial differential examples. Classification: Heat equation: alpha del square u into x comma t minus del u x comma t is equal to 0. A is equal to alpha, B is equal to 0, C is equal to 0, B square minus 4AC is equal to 0. The given heat equation is a parabolic. The wave equation where A is equal to C square greater than 0, B is equal to 0, C is equal to minus 1, B square minus 4AC is greater than 0. So the given wave equation is hyperbolic. Boundary conditions for partial differential equations. To uniquely specify a solution to the PDE, a set of boundary conditions are needed. Both regular and irregular boundaries are possible. The solution methods for partial differential equations are analytic solutions are possible for simple and special cases only. To make use of the nature of the equations, different methods are used to solve different cases of partial differential equations. The methods discussed here are based on the finite difference technique. Solution technique. A grid is used to divide the region of our interest. Since the partial differential is satisfied at each point in the area, it must be satisfied at each point of the grid. A finite difference approximation is obtained at each grid point.